Hello Year 9. We are now getting towards the end of your booklet, so you should be on page 58. The next 3 lessons are going to be part of your seed fall investigative work. So with this work, we assess you both on the content, on the knowledge of the unit that we've just done, normally in a test when you return to school, but we also assess you on your investigative skills in an investigation like this one. So you've been doing investigations all through Key Stage 3, and the terminology that we use, things like variables, independent, dependent, control variables, anomalous results, and graphing skills, they should all be quite familiar to you, So we're going to talk through this step by step on the video, just in case you're not sure what it is you've got to do. So first of all, you need to watch my little video about how to make, a pretend paper sycamore seed. So these are real sycamore seeds that we can see on this image here. And the seeds themselves are actually these sections that are here, And what's special about the sycamore seed, why it spins like a little helicopter, and they're often called the helicopter seed, is that attached to the seed is a very, very thin, very light, papery wing, almost like an aerofoil, just like a helicopter has those blades, that are on them. And because of the symmetry as well, the shape of the seed that we've got there, so it's not quite symmetrical, this makes the seed, when it drops off of the tree, spin. Now, why is that an advantage to a seed, to spin? Well, spinning will keep it in the air for longer. The longer the seed is in the air, the further it can travel away from the parent plant that it fell off of, So we're looking at basically seed dispersal here. The method of dispersal is wind, and we want to know your investigation. The question I want to ask you is, plan an investigation to find out how the time it takes a seed to fall is affected by the size of this wing, So hopefully you should have an idea by now, just from that statement, about what you are changing, the independent variable, and what you're going to be measuring, the dependent variable. And hopefully, if you've watched the little video about how to make the actual seeds, you will have an idea about the range of the independent variable. In other words, what size wings you are going to be cutting, and also some of the control variables that we're going to keep the same. So a little bit of background information. If seeds are being scattered by the wind fall slowly, they stand a better chance of being carried further by the wind away from the parent plant. This means, and this is where the science bit comes in, they will avoid competing with the parent plant for space, sunlight, water, and nutrients. If it's avoiding competing, it's getting more of these resources, therefore it will stand a much better chance of survival. So if we think about other dispersal methods, things like the sticky seeds that, like a burdock, let's stick to animals' fur, why is it an advantage for them to have those hooks? So they can travel on animals further away from the parent plant, so they can be spread to avoid competing with the other plants for space, light, and water. So with our seeds, just have a little think about the bigger the surface area of the wing, why does that slow the seed down, and why might it slow the seed down? So think about when you're jumping into a swimming pool. I know it might have been a long time since anybody jumped into a swimming pool. If you jump in like a pencil jump, straight in, straight down with your arms by your side, you cut through the water really, really quickly, and you hit the bottom of the pool with your feet, and you are super sleek the way you go in, so you don't really make an awful lot of a splash and a mess, If you want to keep your hair dry, jumping into the water, the best thing you can do, is to make yourself have the biggest surface area you possibly can. So you spread your arms out at the side, as if you're doing a star jump, and you jump in, with your legs, bent at the knee, okay, or one leg bent at the knee and one leg bent backwards, okay, to give yourself a bigger surface area. And hopefully, as you jump in, because you've got a bigger surface area, that slows you down, and it means that you don't get your head go underwater. It makes more of a splash, but you don't get your head go under the water. Another analogy, okay, for looking at seed fall is to do with parachutes. So if you are jumping out of a plane and you have a tiny parachute, what's going to happen when you jump out of that plane to the speed, okay, that you travel hurtling down towards the ground, compared with if you have a bigger parachute and you're jumping out of a plane? So I know that in physics, Mr. Ruddy does some work here, to help if his parachute's attached to him, does some work with you here, okay, about cupcake cases, which is similar to this investigation. So the kind of phrases that you should be mentioning when we talk about your prediction and the scientific evidence is the surface area, and there should be a word that you should be familiar with by now, okay? It's called drag or friction. So the bigger the surface area, the more air particles it's going to trap underneath the parachute here, or underneath our wing of our seed, and it's going to slow that seed fall down or that parachute down, okay, as you fall through the air. So you need to be using some of these key scientific ideas and models, okay, to help you to write your predictions. So on page 58 then, the first thing I want you to do is really important, is to identify your variables, okay? This gives us a good idea around about a level 5. If you're able to identify your variables independently by yourself, then it would be a level 5. Hopefully, we'd like to move as many of you to a level 6 and a level 7 as we possibly can. So I'll explain to you how you achieve the higher levels in a second. So remember, the independent variable is the variable that you change. So thinking back to the video of how to make the seed, what did we say we were going to change? And how will we do that? So with the scissors, we could cut the slit. We folded the wings back. That size of the wing, a better way to phrase size of the wing would be to look at the area. So because I used gridded paper, I could count the squares, but if you use a ruler and measure the length and the width, then you can use that to work out the area of one wing and the area of two wings. Don't forget your seed has two wings, okay? You also need to think for the higher levels, okay, what the range is of your independent variable. In other words, okay, what sizes of wings are you going to do? Are you going to go 1 centimetre cut, 2, 3, 4, 5, 6, 7, 8, 9? Are you going to go 2, 4, 6, 8? I can't do 10 because that will cut it in half. Are you going to go 1, 3, 5, 7, 9? Or are you going to start from about 2 and go 2, 3, 4, 5, 6, 7, 8 in the middle? So you decide on the range of the size of the slits you're making. Bear in mind, if you cut the slit 5 centimetres, then the area will be 10 centimetres squared, because there would be 5 centimetres squared on this side and 5 centimetres squared on the other side, making a total of 10. So be really, really clear here whether you're doing the size of the slit, the size of one wing, or the area of both wings, okay, when you're describing your independent variable. The other way you can get higher levels, okay, level 6, okay, is to state the interval. So if you're going up as 2, 4, 6, 8, your interval is every 2 centimetres, okay? The next variable is your dependent variable. What are you going to measure? So you saw me explain that you might need your phone or a stopwatch, okay, or a watch of some kind. You're going to be measuring the time it takes for the seed to fall. So you're going to have to start your stop clock the moment you drop the seed, and you're going to have to think about where you're going to do this, so I'll mention that in a second. And you're going to have to stop the stop clock the moment it hits the ground. You might want to employ, if you've got any brothers or sisters, or if mum and dad can give you a little bit of extra time to help, okay, over the weekend to collect your data, then that would be absolutely perfect. It saves you having 2 pairs of hands. Or you're going to have your phone and the seed in your hand at the same time, or your watch on your wrist, okay, and your seed in your hand at the same time to be able to do this, okay. Control variables now. These are what you keep the same to make it a fair test, okay. And in order to help you get the higher levels, okay, if you can explain how you will keep them the same and why they need to be kept the same, then that's really important. In the video that I made about how to make the seeds, I described you could use any paper you like, but whatever paper you use, all your seeds have to be made out of the same type of paper. They also have to have the same area of the paper making up the seed, 10 centimetres by 2 centimetres. So the same thickness of paper. So you wouldn't use toilet tissue is not going to be ideal because it's just too soft, but you wouldn't use say a toilet tissue that had 5 layers in it and a toilet tissue that had 2 layers. It's not comparable, it's not fair, okay, because they would have different weights to the toilet paper. Other control variables, you're going to have to drop it from the same height each time. Now, word of caution here, some safety. Please do not stand on a chair, okay, or anything like that. I do not want to risk anybody falling off of a high surface, okay, and injuring themselves and having to be taken to hospital, especially at the moment, okay. So wherever you drop it from, have a little think about around the house where might be best. So if you've got stairs and a landing, sometimes that will allow you to stand at the top of the stairs very carefully, mind, okay, so you don't fall down them, and drop the seed over the side, okay. Or you might have to be in your lounge or your kitchen, okay, and just hold it at the top of a cupboard, okay, slightly away from the cupboard, okay, and drop it down. So if you've got a tall parent or a taller sibling, that certainly is going to help you, okay. So be very, very careful. Do not stand on wobbly chairs and tables and things like that. When we do this practical in school, we get you to stand on the desks, but only the solid desks, the ones that have a base that have the gas taps attached to them, so they are fixed to the floor. They're a kind of permanent feature. We would never get you to stand on a stool or a desk, just in case you were to fall off. So you've got to think about the height that you drop it from. That has to be the same each time. You've got to make sure that wherever you're dropping it, you haven't got an open window, okay? So if you are doing this outside, if you decide to go outside because you've got some steps and you can stand on the top step in a steep garden, for example, and drop it, okay, then please do it when it's not windy, and you probably don't really want to be going out when it's wet either, okay? The way you drop it is important as well. You're not going to push that seed down. As in the video of making the seed, I show you holding it between my fingers, okay, and then just removing my fingers really quickly to let it drop, okay, to let it fall. If it doesn't spin correctly on the way down, if it's a kind of lopsided, okay, then just repeat it until it does spin. You want it spinning nicely, okay. Some with the smaller size wings may take a time to spin properly, but as long as you've got your paperclip weighted correctly in the middle and your paper is cut accurately, okay, it should spin. So you're going to drop the seed, you're going to measure the time it takes to fall. The same paperclip has to be used as well, okay, because if we change our paperclip partway through, it might have a different mass. So as it falls, it should spin. You measure the time it takes from the time you drop it to the time it hits the floor, and you will record that. It will be in seconds. So we'll need to design a table later on next lesson to collect our data. Okay, so this first bit is all about the planning. Are you just going to rely on one set of data, or are you going to repeat it? Think about in practicals in the past in investigations, how many times do you normally repeat it to collect your data? If you repeat it with the same size wing and you get two really different results, we might say that one of those results could be an anomalous result. An anomalous result is a result that is a little bit odd, unusual, it looks different. It's either higher or lower than the others. So you can, by all means, repeat the results if you think that you've got any anomalous results. So I want you to pause the video at this point. I want you to write down your independent variable with the range and interval if you can for higher levels, the dependent variable, what you will measure, and all of the control variables that you can remember from our PowerPoint, from our video, okay, and how you will keep the control variables the same and why. I then also, on page 58, would like you to write a prediction about what you think is going to happen, okay, as you change the size of the wing. Now, when you write this, you should always try to link the independent and the dependent variable. If they're both continuous variables, in other words, if they're both numbers, okay, continuous variables, then we should be able to write a link, a clear link. And we try and use these terms increase and decrease rather than go up, go down, okay, right? So have a little think about what the results would look like on a graph, okay? So if we had a graph of our data, this is before we've even collected it, we would have size of wing down here, and that's going to increase as you go that way. And the time to fall would go this way. So do you expect your graph to have a shape that looks like that? A shape that looks like that? A shape that looks like that, or a shape that looks like that. So if you've got an idea roughly what you think is going to happen to the time it takes as the wing gets bigger, as it increases, okay, then that will help you to clearly write it. So if you start with if, and then your independent variable here, size of wing increases, then, and this would be your dependent variable, does it increase? Does it go up like that? Does it decrease? Does it go down? Or does it stay the same? Or does it increase, peak, and then decrease? So in your prediction, if you can sketch the shape of the graph that you think you will get from your results before you collect your data, and then write your prediction with your link. Now, your prediction also needs an explanation for higher levels. You should include some correct science knowledge, okay? So think about the forces on the seed during its flight. So as it's falling down, what force is bringing it down to Earth? And as it's coming down, what force is slowing it down, okay? Because of a big surface area. So we use these words, resistance is the force going down. Gravity is the force going down, and air resistance or friction is the force that goes upwards, okay, and stops the seed falling as quick as it could do. You can use analogies. An analogy is comparing it to something that happens in real life. So that's why I used the parachutist, the person jumping into the water, okay, the cupcake investigation that you sometimes do with Mr. Ruddy. The best predictions give us a quantitative link between two variables. So instead of just saying increases or decreases, they might say that one variable doubles or halves, okay, as the other one doubles or halves. And this might lead us, okay, to a particular shape graph, okay, where the relationship between the variables, okay, can be clearly seen, okay, as a proportional correlation, okay, and that can be a positive or a negative correlation. So we're going to stop at that point.